Hi everyone, welcome to Online Study for You. My name is Ankan, and in this video, I'm going to discuss some previous year coding questions that have appeared in the TCS NQT examination. Now, before I do that, I just want to mention the very important DSA topics with respect to the coding questions of TCS NQT. So as you can see on my screen, in the topics, we have basically all of the DSA topics, which includes arrays, linked lists, stacks, queues, some searching and sorting algorithms, binary search, dynamic programming, recursion and backtracking. Then we also have questions from trees, graphs, heaps, tries, and even some questions on bit manipulation. Now, apart from this, the most important topic, as I have seen, the most number of questions have actually come from arrays, some questions on greedy algorithms, or some matrix related questions, or even two pointers. Now, in the previous year, which is 2024, TCS NQT had questions on these particular topics. A lot of the questions were again from arrays. Then we had questions on linear search, bit manipulation, dynamic programming, linked lists, and stacks. But once again, the main topic here will be arrays, as the most number of questions was from that topic. So in this video, we are actually going to cover two different things. Now, in some previous years, when I had a talk with a lot of candidates, many of many of them had actually faced the same issue, that the user inputs of the coding questions in the NQT examination were very tricky, right? So a lot of them actually had problems while taking inputs. So I'm going to solve that in today's video. So first, we are going to take some very tricky user inputs, and I'm going to help you on how you can take these inputs very, very easily and very, very conveniently. And then we are also going to cover one previous year coding question from TCS NQT. All right. Now, before I move on to the actual video, I just want to mention that we have a TCS NQT very special crash course, which consists of live classes as well. And as you can see here, that in the previous year in 2024, we actually have more than 5,000 selections through this TCS NQT examination, which is quite incredible. And yeah, you can read about this course. So some very key important features here. We have 800 plus learning materials, and among the content, you will get live classes. So live classes are already going on, and you will have questions in both C++ and Java. So you'll also get the TCS NQT previous year questions, and here you'll also get some C++ questions as well as Java questions. So we actually have all the PDFs here. You'll also get notes. You can also see we have some fully solved questions of previous year TCS NQT. We have codes again in both Java and C++. So yeah, do check out this course. The live classes are also going on. And also, as you can see, you can avail this off. We have 56% off. All right, so let's get started with the video. All right, so as you can see that I've opened up a C++ compiler. So I'll start off by doing the very basic and very simple inputs. So let's say we have an integer a here. We can simply take an integer input. That is how we take an integer input. It's the simplest of things. And we can definitely print it here. Right? So it's an integer. Your C in A means we are actually taking it from the stream. So we are asking the user to input it, and we're going to take the number from there, and then we're going to print it. So if I run this program, and if I give it some number here, right, 12, I'll just give it 12. And you can see it prints number as 12, right? So it simply takes it from the input. So this was for the integer. A very similar way of doing it for the other data types would be, if it is double, you can simply change this to double, right? If it is a character, it also becomes similar. So let's test a double. Let's say it's 12.67 or something. So number becomes 12.67. Similar thing you can do for char as well. So if you want to take a single character, you can simply do it like this. So this would be a single character. Let's say we take C, it will simply print character C. Now, what will happen if it's a string? So let's say you have a long string, right? A long sentence with various spaces also in between, and you need to take the whole string as an input straight away. So for that also, it's pretty similar, right? So you just take a string here. Maybe for better naming convention, I mean, for better variable naming convention, we take str, cin of str. If you do this, it will only take a word as an input, right? But you need the entire line, okay, which can contain spaces or anything. So for that, what you can do simply is, you can simply, instead of doing cin str, you can use the keyword get line, right? So you can use get line, and you can do cin comma then the str which you have taken, right? So here you can just put string, and if I run this, okay, I can make this a bit better. So I can write here enter a string, right? Okay, I can put up a next line here, ender. So this should be for the entire string. Okay, okay, I also need to change this to str. Okay, if I run this, okay, so here I will actually input a long string. So let's say my favorite food is idli, right? And if I enter here, you will see the string will be my favorite food is idli. Okay, so this was for when you need to take the entire line as an input, right? Easy. Now let's say, okay, so now apart from the data types, like okay, we can also do the same for boolean as well. It will be bool, right? So if it would be boolean, it will simply be bool b, and it can either be true or false, as we know for boolean inputs. Now some of the inputs, what as I saw in some of the previous NQT questions, you might need a bit of a different approach. So we have something called as a string stream in C++, where we can what it is that it's a stream. So if you look at this sentence, get line cin of str, or if I take even a simpler example, right? If I just take an integer, right? Cn of a. So in this line, cin is actually a stream, right? The user is inputting all the things as a stream, and we are simply reading it from the stream. So cin of a essentially means we're reading it from the input stream. Similar to this, we have a string stream, which we can define like this. So string stream, let's say SSO or SS or something, right? So you can simply, just like cin, you can also read it from this string stream SS. In like the syntax is pretty much the same, right? Instead of cin, it will be SS. So how do I test that? So let's say I have a string, right? Okay, I have a string, and actually let's have a number. Like, why not? Let's have a number as a string. So what I'm going to do is, I'm going to insert this number string into the stream, right? I'm going to insert this 44 string into this stream SS, and then I'm going to read again from that stream, from this SS stream. Okay, so string number equal to 44. I've defined my string stream object, and now what I'm simply going to do is I'm going to put this number into this stream, which is SS. How do I do that? It's very simple. SS number. So this symbol is very simple, very similar to the C out symbol which we have, right? So here I'm inserting the number into stream, right? Yeah, into the string stream. Why I'm doing this? In order to test out how I'm going to read this again from the stream. So now at this point of time, this number no, or rather the string no, is actually present inside this string stream SS. Okay, so now I can read the number back from the string stream in a very similar way. I read a number from cin when the user gives an input from cin. So the very similar way, same syntax. Instead of C in, it will be SS. So SS NO. So I'm reading the number back from the stream. Okay. So for the number, okay, C in of N, okay, I have to take a different name here. So let's say I store that integer in int N or something, right? And then I'm going to take that number back from the stream. I inserted it here. So now I'm taking the number back from the stream. And now if I print this number, let me see whether I'm getting this number or not. Okay. So if I print this number, so remember one thing, when I entered it, it was a string, right? Into the string stream. But when I'm actually getting it back from the stream, I've actually defined it as an integer. So let's say if this works or not. But if this works, this N is always an integer. Okay, N is always an integer, we know. So if this Cn works, which is reading from the input, reading from the stream works, then number 44 will be printed. Let's print N here. Okay. If I run this, okay, we are getting it. Okay, we don't need this particular line here. If I run this, it will be printing 44. So what we did here, we took a number string stream, actually for 44 is a string. We put it into the stream, right? And then we took it back from the stream. Then we read it back from the stream, and then we printed it. Okay. So this is pretty similar to the C in which we do in C++, right? Because there also we are reading from the stream only. That's the user input. Okay. So this was a bit about string stream. Now, why did I discuss this? Because I feel a lot of the inputs which we had in the previous year questions of TCS NQT could have been solved pretty easily by using string stream. Okay, so let me discuss a bit about those inputs, a few of those inputs. All right. So all right, so let's actually try over with an input. So this was a pretty similar kind of input actually came up in one of the previous NQT papers. So let's say you have an input like this. So you're given a coding question, and in the input, it's saying like this. You have two input in this order: 23.45. Let's say we have some string here. Let's say ABC, and we have 78 over here. Okay. Maybe we have one more line, 34.56. We have HGI, some random string, and let's say we have 990. So, okay, I'm commenting this out, yeah. So let's say you have this input, right, which you have to take, right? You have to take this input, and you don't know how many lines you have, right? You have no idea, like N is not given to you. The number of lines, N is not given to you. So how are you going to take this input? Because this is just coming, right? The user is just giving it. He or she can give like any number of lines, right? So here, the string stream will come into account, because what we are going to do is we are going to put all of this into a string stream, okay? Which like we are going to just check, if the user is at all giving something here, right? If the user is at all inputting something, if the user is at all inputting something, we're going to put everything into a stream. And after we put everything into a string stream, we are actually going to read it slowly from here sequentially in order to get all of these values individually. So so the main point here would be how do we read from the string stream in a very sequential manner. All right. So, okay, let's say we have to store all these values in separate vectors, right? In separate C++ vectors. So let's say all floats I want in a separate vector, all strings I want in a separate vector, all numbers I want in a separate vector. Okay, so in order to solve that, let's actually start to solve this. How do I actually parse such an input? Okay, so I need to store all of these into separate vectors. So I can maybe create the vector first, right? So vector of float, F, vector of string S, and vector of, we have the integer as well, integer V or something. Okay. All right. So, okay. So I know that each of these lines are actually a string. Essentially, it's a string, right? So I can actually check that how many times the user is actually inputting a string into the, through the console from where we are actually reading this. So I can take a string str or something. And we already discussed how do we take an entire line as a string input, right? So it is, what was the syntax? It was get line of cin comma the str which we have, right? So until and unless, okay, so unless, like until or till, whatever you want to say, till the user is giving a string input, this loop will run, right? So for every time, like every time the user actually gives a string input here, we are going to run one iteration of this loop, right? And for every iteration, we are going to take this as a single string, put it into a string stream, and we are going to read this sequentially. All right. So I'm going to put this into a string stream. String stream SS, put this str here. Okay. Now, how am I going to actually, okay, I have to separate out what? I have to separate out the floating string and number. So maybe what I can do is I can, okay, one thing to remember is that this whole thing is a string, right? So when you parse this 23.45, it will also be a string because the whole thing is a string. So you actually need to convert it into float before you can store it in this vector. So, okay, so for that, let's take a string f, right? Now what I'm going to do is I'm going to parse this SS now. I'm going to parse this SS until we get the comma. Okay, we can separate it by commas. So while same thing, get line, while get line in comma. Okay, I'm going over what? I am going over. Oh wait, we don't need the while loop here, right? Because we are already getting into a single line. So for every iteration will be a single line of input, right? So now we already have it stored in our string stream, right? So here we can simply do a get line, right? We can simply do a get line. So we have this entire thing in our string stream now, right? And now we are reading it from the string stream. How do we read it from the string stream? Same thing, get line. In the get line, I am going to put SS, which is the string stream. Then I'm going to read F, which is this. I'm going to store it in F. And what I'm going to store? I'm going to store everything which is before the comma. So everything will be separated by commas. So I can maybe just put a comma here, right? In this way, F will contain for 23.45, but it's a string. So I need to convert it. So before I push it into my vector, what I'm going to do is I have to convert this. How do you convert a string to float in C++? In the quickest way. You have a function called string to float, right? So it will be string to float. So stof. So we have also have a string to integer stoi, which also we will need when we parse this. So stof, and I have to put f here, right? Okay, the names can't be similar. Okay, we shouldn't do this. The names can't be similar. Fo, fo. Okay, so f was the name of the vector, so the string cannot be fo again. Okay, so that is how we can do it. And then I guess we can. Okay, so we have already read up to here. Okay, we have already read up to here. From the stream, we have already read up to here. So now the pointer is at A. Okay, so again, we have to do the same thing until the next, until the next comma comes in. We have to again get line. So same thing, SS comma string. So I have to take another string here. String we haven't used. Okay, string, let's say SO or something. Okay. Read this again. We already have the string vector. I'm just going to push it. Now this is already a string, so I don't care. And I'll just put it as a string. And now the final thing is float. So I'll just do, final thing is integer, 78. So I'll just do the same thing here. Just copy this and paste it. Okay, this will be an this will be a string. So this will be a string integer. And this will be integer here. So I am moving it until the next comma essentially. And okay, and I have to put here integer. Okay, what was my name here? V, right? So v dot pushback integer, right? So this should actually do it for the first line. And since this loop is running, so every time we have a line, so this essentially means every time a line exists, we are going to do the same thing and put it back into our three individual vectors. Now, if I print one of them, right? If I print one of the vectors, let's say I print the integer vector, right? So here I can simply print v of I, right? Okay. First, let me check, do we have any syntax errors or not? Okay, we have a syntax error. What's the error? Okay, v to integer, I have to convert it, right? STOF, so yeah, it will be STOI. I have to convert the string to an integer because it's an integer vector. Okay, let me run this. Okay, so I need to give the input now. Okay, so this input will be pretty similar. So 23.45, comma ABC, comma 78, right? So if I enter here 34.56, or I cannot test this maybe here because this stream here, by the way I'm taking it, so it will be continuously getting inputted. But then what will essentially happen is, this is how the numbers will be stored, right? All right. All right, so I actually found out a very good way of testing this. So why not, instead of doing this, why not we put it into a string like this, okay, and use this slash n operator, which denotes next line essentially. So if we do it like this, right, and if we follow the exact same thing which we did and we print out the numbers, you see we are getting numbers here. So if I run this, you will see that we are getting 42 and 24 here. Okay, so while handling such kind of complex inputs, I think this was one of the in one of the questions we did have very similar kind of inputs in one of the previous NQT examinations. So yeah, this is exactly how you can handle it, right? So you have this, right? You have this continuous string coming in. Here you have one string, the next string, and third string, and so on, but you do not know how many lines you have. So the easiest way of doing this is, you put this here, right? You put this here like until you are getting something, and until you're getting something in the stream. Then what you do is you just put everything into a stream, and then you read it from here. So you read the first part until you get the first comma. That is a float. You convert it, put it into the float vector. You read till the next comma string, and you read till the next one, which will be the integer. So now you have to do this for every line. So for that, you already have the while loop running here until and unless you are getting something in the input. So all the numbers are automatically stored here. All the strings are stored here. All the floats are stored here. If I run it for the floating values as well, right, which is it's stored in F. So if I print this, it should be giving me 3.14 and 2.71, as you can see, right? Now, even if I, I can go into the next line. I can also increase this, right? I can also do it like 5.78, comma, earth, comma, 78, something like this. If I do, and if I run this, you will see that again, 5.78 is also stored here. So 3.14, 2.7, 5.78. So this can be endless essentially. I mean, it won't be endless, but you don't know, like when you don't know how many lines are there, right? So you can take this as a stream here. Okay, you can take this as a stream, and this is how you can do it. You can add any number of lines here. Okay, this won't be affected. Like this code won't be affected. This code will run for any number of inputs or any number of lines which you have here, right? All right. So this was one of the like among the challenging inputs. So this was one of them. Now we have one more inputs, which I guess is a bit simpler, right? So let's say we have something. Okay, we have something very similar, but we won't have this slash n here. So we won't have this slash n. Rather, we'll have a comma here, right? We won't have this slash n. We will have this comma here. Okay. So how are we going to do this? Like one very simple way of doing this without stream, okay, because you might not need essentially stream here. So one easy way of doing is that you take the whole thing as a single string, and then you go over all the numbers. Okay, you can go over all the numbers. Actually, this actually instead of comma we had a semicolon here, so that makes it even a bit simpler, right? So what you can do is you can simply separate by semicolons first. You'll get each segment you can separate it by segments, and then you can separate that single segment further to get this, this, and this, right? So that will be even much simpler than this, because you won't need a stream in that case. So in that case you won't need the stream here. Rather, you can just simply take the whole string and divide it, right? So if I want to code this one as well, it will be very easy. So okay, first, okay, I don't need this, I don't need this, I don't need this. Input data. Okay, so what I will simply do is I'll simply do get line cn comma input data, right? So I have the whole string with me. Okay, essentially I am not taking it from cn, so I shouldn't be you using this. So I'm not taking it from the input now. I already have the input with me, so I can just use that, right? Okay, so now I have to break this into segments, and then from every segment I need to pick all of them separately. All right, so let's do that. All right, so yeah, we can simply separate this by semicolons and do it. Now, one thing I thought, one thing I thought about this, why not we follow the same process which we did in the previous question, right? So why not we take a string, and then again, we take on all the inputs, and then again, we split it by semicolons, then put it back into the string stream, and then read it from the sequentially, separated by separated by semicolons, since we have it here. So why not we do it like that, right? So again, the same thing follows until and unless I'm getting something into my input. Okay. So for doing that, I need to store it in a string. So for while get line, I can simply do, so I have the string stream right now. I haven't taken the string stream. So string stream SS, take this input data. Okay. Okay. Now I'm reading it from the string stream, right? So it'll be SS here, SS comma str. str, and I will be separating it by semicolons now. Okay. And here it would be the same essentially what we did in the previous question. So we had a float, we had a string, we had an integer, right? Okay, we already have the vectors defined, so I'll just push it. F dot push back, same thing. stof, I'll be pushing this one. So I have this now in my string, right? In my str, when I'm getting it separated by semicolon. So my str contains this, right? For now. And then again, before I push it, I again need to separate it by commas. I need to separate it by the first comma. Okay, so my str contains this. I hope I'm clear. My str for now contains this, right? So I have it here. So before I push this, what I need to do it, I need to take it till the first comma. So I again need to do the same get line. But now this time get line will be of the str, because my str contains that, and I need to store it in fo, and now it has to be separated by commas, right? Now it has fo here. Same for the next thing. We're going to continue get line str again. It would be stored in so, and again up till the next comma. Okay, and the next comma will have be in the next string, which is s dot pushback. What happened? Yeah, s dot pushback will be so. So this part is absolutely same as the previous question, and then we take the final part, which is get line str. We have, what do we have? We have io, right? All right, that will be pushed into vector v io. Now one thing again, this is a string io, so I need to convert it into integer stoi io. Okay. Yeah, so I guess we are done with the pushing of elements. Now I can print any of the vectors. So let's say I want to print the integer vector. Why not? Just loop over. Right? And I can simply do integer, and I'll print v of I. Right? Okay, I think this should be good. Okay, I can give a space here. Okay, I hope this is good. Okay, if I run this and let me check how many errors we have. Okay, what is the error? str no matching for call string and char, right? But what is the error? Get line str str. Okay, fo. Yeah, so we are getting line fo is a string, right? So we are converting it. Fo is a string, we are converting it. Wait, where did we? Wait, this has to be the string stream, right? I have to read it from the stream, right? So just a second. This will be so or whatever we name it. Okay, what happened? Control. But something happened by keep mouse cursor. Just a second. All right. So what is the error? The error is that I have to read it from the stream, right? And not from the str. I have to read it from the stream. So I need to put it back into the stream and then read it from there. Okay, so we cannot read it from the string. My bad. What? It's a simple solution. I just define a string stream. Yeah. String stream of SSO, and this will contain what? This will contain the string. Okay, so we cannot read it from the string. So we cannot directly from the str. So instead of that, this is stored in an SSO, and then we read it from there. Same as the previous question. Okay, if I run this. Okay, so it's actually working now. Integer 42, 24, and 78. 42, 24, and 78. Okay, so this is how you do it. You take you check it for every time, you know. You first okay, so this is one line. So you take it in a single string, right? And you separated it by semicolons. Individually, you put each of them in a string stream from where you can read it sequentially one by one and store it. That is it. Okay, so that is how I guess we can take these kinds of inputs, which are quite common now in the NQT examinations. All right, so that was it about taking inputs. So now let's actually move on to a coding question, a very famous coding question, by the way, of NQT. All right. All right. So the question is majority element. Okay. If you look at this question, it's a pretty simple problem. You have a vector full of elements, and you need to find out the majority element in that. What do you mean by the majority element? Any element which appears more than n by 2 times. That is basically the majority element, right? So on first glance, you might say that it's a lead code easy question, and indeed the brute force or even the better approach is very very simple. So okay, if I okay, what is example 22111122? Okay, so let me just write it here. We have two. Okay. Uh, we have 22111122. Okay, but before we go there, you tell me what is the brute force approach that you guys are thinking, right? The brute force approach for this will be uh, you will simply take two loops, right? You simply take an outer loop, you simply take an inner loop, and for every I, you actually traverse over the entire vector, right? And then you check how many times, has this element appeared again or not. If this element has appeared again, you increase the count. So for two, if you go here, okay, so two's count is one, and for two, you traverse the entire loop. Has two appeared here? Yes, two has appeared here, so count becomes two. Here count becomes three. Here count becomes four. So count it becomes four. Is four more than n by two or not? What is n here? 22111122. So n is seven here, right? So n is seven. Seven by two is three. So we are taking the floor value, and the count was four. So essentially, um, four is more than that. So two will be our answer. Okay. Let's read this again. 22111122. Okay. So we have two, 1, 1, 1, 2, 2. Okay. I hope you can see my screen. Okay. So for every two, you are going to go over the vector, right? So the outer vector will be for each two, like for every I equal to zero. I hope it's clear. The outer loop will run from 0 to n, where n is like 0 to less than n, where n is the size of the vector. So for every I, you check j. So for every, so if first I will be equal to 0. So 2 is present at the zeroth element. So for this 2, you are going to check if we have any 2s over here. Yes, we have. Yes, we have. Yes, we have. So at present, the count is 1. But then when you reach here, count becomes 2. When you reach here, count becomes 3. When you reach here, count becomes 4. So count is equal to 4, right? And if count is equal to 4, then you know that the size of the array is 1, 2, 3, 4, 5, 6, 7. Okay. So 7 by 2 is 3. We will take the ceil value, which is a 3. So 4 is more than 3. Hence, this 2 is our majority element. So our answer will be 2, right? That is the simplest approach. Now tell me what is the time complexity of this approach. Tell me what will be the time complexity of this approach. Take our time complexity of this approach, since we are using two loops, it will be O of n square, where n is the size of the array or the size of the vector, whatever you want to say. Okay. So that will be our simple approach. Obviously, the interviewer won't be happy if you're in an interview, or even this is not the most optimal solution, but you guys can obviously check out the constraints here. Okay. So if you look at the constraints here, this won't work. Okay. Because n square will be 10 into 10 power 8. And I guess most compilers actually work up to 10 power 7. So if you so 10, so it'll be 25 into 10 power 8 is approximately 10 power 9. So this won't work. This will give you time limit exceeded, right? So that this will essentially give you time limit exceeded. Okay, TLE. So obviously this won't work. You need to make this better. So how do you actually make this even better? One way which comes into in our mind is if we use hash maps, right? If we use maps in vector, I mean maps in C++. Okay. So if we use maps, that will also be very, very simple. Let me write this again here. 2 2 1 1 1 2 2. Right. So what I'm going to store in the maps, the frequency, of course. So frequency of 2, essentially if the map is M, so M of 2 will be 4, right? M of 1 will be 3. And that is it. Okay, so M of 2 will be 4, M of 1 will be 3. Now we are going to loop through M. Okay, this, let me just rub this. Okay. So now we are simply going to loop through this map. We are going to check the second property. So I hope you are aware of pairs in SC++ STL. So we are just going to check the dot second property since we are storing the frequency in the second part of the map. Okay, so this is the key. So this part is the key, this part is the value. So we are going to check the value. And if the value is more than n by 2, same thing, then we are going to say that this is the majority element. So let's code this approach out. I guess it will be better. Okay, so I'll just quickly rub this. All right, I'll just quickly rub this. And okay, let me just put myself here. You guys have read the question. I'm pretty sure. So I will have to write this. So before that, let me just put this over here. And okay. All right. So what has been given to us? We are given the nums vector, right? So what I'm going to do, I'm going to simply define a map. You know, the map will be of int comma int, right? Okay. So this would be storing our key value pairs. What is the key? The key is the number. The value is the frequency. Right. Now, what I'm going to do is very simple. I'm going to loop over. Okay, this is nums.size. And very simple, I'm just going to do MP of nums of I plus plus. So what is happening here? I'm storing the frequency in its respective number. So frequency of 2 will be stored in MP of 2. Okay, so the corresponding frequency will be stored in the corresponding number as the index number of the map, right? So once I store this, it becomes very, very easy. I'll simply loop over the map. I hope you guys are aware of the iterators. Okay, so it's a part of C++ here, pairs, vectors, and maps, and iterators. So this is very simple. I iterate over every value of the map. And what do I need? I need the second property of the map. Why? Because this is number comma frequency. And I am concerned with only the frequency, right? I'm just going to check if this frequency is more than n by 2 or not. As simple as that. So I'm simply going to check if it.second is more than n by 2. N is what? Nums.size, right? So I can simply do this. If it is more, then I know this is my majority element. So I can simply return it, right? I can simply return it dot first, right? Because I'm returning the number and not the frequency. Okay. So it dot first is the number, it dot second is a frequency. As you can see, we are looping over the map, right? So yeah, if I return it from here, I guess that's it. If the element is found, right? But if the element is not found, then what? If I read the question, okay, you may assume that the majority element always exists. Okay, so maybe that won't come here, but in case it doesn't exist, maybe I can still keep it return minus 1 here, although this won't ever happen. Right, so if I run the code and let me just find out if you have any errors. Okay, we don't have any errors, so this is accepted. If I submit this, okay, it's accepted. Wow. So, okay, first tell me what is the time complexity of this approach? The time complexity of this approach will be, okay, so we are using an ordered map here, and for the ordered map, insertion. So we are looping over essentially. So that is O of n, and insertion might take log of n essentially. So looping over and insertion. So it will be O of n log n. Okay. This will be O of n log n. And we are also using the space, right? We are also using a space of O of n. Why? Because we are using the map. If we use an extra vector, if we use an extra map, then it will be the space complexity will be O of n, where n is the size of that particular data structure. Here it is map. And since the size of nums is n, so essentially the size of maps is also n, because that is what we are doing. We are actually calculating the frequency. So frequency of those many n numbers, right? So space complexity O of n, we are using an extra map. Now, what has the question asked here? That is very, very important. What is the question asked here? The question has asked that could you solve this problem in linear time, which you are not doing here, first of all, and O1 space. Okay, so this approach will also not work. Although this is better, this is not O of n squared, this is better than the previous approach, this still won't work. We need to optimize this further. Okay. How do we optimize this further? Okay, that we need to think now. All right, so what were the array elements? 2, 2, 2, 1, 1, and 2, 2, right? I'll just quickly try to write it down over here as well. Okay, this is 2, 2, 1, 1, 1, and 2, 2. Okay, so it'll be 2, 2, 1, 1, 1, and 2, 2. Okay. So we are going to follow a very famous algorithm here, which we commonly know as something known as the Moore's voting algorithm, right? So, okay, if I write it here, it's known as, okay, let me write it properly. So it is known as the Moore's voting algorithm. Okay, the name sounds like that, but it's a very easy algorithm. Okay, Moore's voting algorithm. All right. Yeah, it's better I type it. Okay, so what does the algorithm state? That is important. Okay. The algorithm states that what we are going to do is we are going to assume that the first element is our majority element. We're going to assume that, right? And then we're going to traverse. If I find the same element again, which is our majority element which we have considered, if we find the element again, we'll increase the count. If we don't find it, we will decrement the count, right? And if my count becomes 0 at any position, that essentially means the number which we did consider as the majority element, that is not true. That is not true. Hence, we have to consider the next element again as the majority element. What do I mean by that? Okay, so let me try to pen this. So the first we have 2 here. So we will consider true as our majority element. Okay, so now I traverse it. Okay, when I consider this as the majority element, count is 1. Right. So now I go here 2. Okay, is 2 same as the 2 which we considered as a majority element? Yes. So count becomes 2. Then we move here. Is 1 equal to 2, which we considered? No. So count have to be decreased now. Is this one equal to 2? No. Count has to be decreased now. Now the count becomes 0. So now I have to consider the next element, which is 1, as our majority element. So majority element now is 1. But before I move on, what does this count equal to 0 mean? Count equal to 0 means in this portion, right? In this portion, 2, 2, 1, 1, we had considered 2 as our majority element. But in order for an element to be the majority element, it has to be more than n by 2. And n here is 4, right? 2, 2, 1, 1. 2, 2, 1, 1 is 4, and 2 is only present 2 times. It's n by 2 times, but it's not more than n by 2 times. So this is not the majority element, which means there are other elements, there are other elements than 2 which are also present equal number of times. And if the other elements are present equal number of times, then 2 can never be the majority element. So count equal to 0 signifies the number which we considered, which we assumed to be the majority element at first, is not the majority element. Okay, so we need to consider the next element. So we need to redo it again essentially. And the next number which we essentially have here is 1. So we consider that as the majority element, and then we continue our approach. Okay, so m is 1 and the count again here is 1. Okay. Now I move the pointer here. Count is 2. Is 2 equal to the majority element? No, so count becomes 0. Count becomes 0. Okay, count becomes 0. So again, I move on here and I have to consider this as the majority element. So count becomes 1. Now look, the array has finished. Okay, and I have this pending element as my majority element, right? So that means I have this element remaining. I have this m equal to 2 remaining as the extra element after cutting off all the other elements. Like this 22112, right? So before this 2, we have 22112. So this, all of the elements have essentially cancelled each other, and this element is extra. Since this element is extra, this is the majority element. Why? These 3 2s have been cancelled by these 3 1s. Essentially, we do not have any majority element in this part of the vector or array. This 2 is extra, which means this is our majority element. Right, because these elements have cancelled each other, and anything which is remaining extra will be our majority element, because the frequency will be the greatest. And if you look at the frequency, it's 2 at it's 4, right? 4 is more than 7 by 2, which is 3, and indeed it is the majority element. So all the elements which were already there have been cut off. Like, okay, I mean, the elements have cancelled each other, right? Essentially, this is the extra element, and this is the majority element. That is the concept which you are following in this Moore's voting algorithm. It's a very simple algorithm, and let me code this out. But before that, tell me, what is the time complexity of this? The time complexity of this will be O of n. So it won't be O of n square. It will be O of n, right? Because we have we are just traversing the array once. Okay, it's O of 1 n essentially. And what will be the space complexity? O of 1. Why? Because we are not using any extra vector, any extra map, or anything. So it's just O of 1. Okay, very simple algorithm. Let's code this one out. Okay, so let's actually move back to my coding screen. So let me just take a second and let me just move back, right? Okay. Okay, so I'll just code this one again. Okay, so what did we do? We had to loop over this vector. I less than nums dot size I plus plus. And what we simply have to do is I need to consider the first element which you have as my majority element. Okay. Now before that, I need to define my count as well. So let's say count is always 0 at the beginning, and my majority element. Majority element. Right? I'm going to check if count is 0, which is 0 for now. So whatever is there in my ith index, I have to consider that as my majority element. So nums of I. And again, the count is 1, right? Because this is one of the elements, so the count is 1 now. Now, if I simply need to check if what? If the element which is present now, if it is equal to the majority element which we have considered. If it is, then we do count plus plus. If it is not, we do count minus minus. Okay, that was our concept. And at the end, we are simply going to return the majority element. Okay. I hope I haven't done any mistake here. Okay, I haven't done any mistake here. I'll just submit this. Let me check if it gets accepted or not. Oh, it's accepted. Wow. So yeah, so that was our algorithm. The time complexity is very simple. Time complexity will be O of n. Case complexity will be O of 1. Why O of 1? Because we are not using anything extra, any extra vector, any extra map, any extra data structure, right? That's why O of 1. Any extra data structure we use, be it stacks, queues, vectors, maps, it will be O of n, where n is the size of that data structure. And time complexity here is O of n because it's just one loop here, right? It's just one loop. It's just one loop. And it's just one iteration even. So it's just O of n, right? All right, so that was about it. This was the most optimal approach. Okay, so we discussed 3 approaches. This was the most optimal approach, which would be very good in the coding round as well and in the interview as well. All right. And before I end the video, let me tell you that Online Study for You has a new TCS NQT crash course, which is being launched, especially targeting for 2025 batch students. We already have more than 5,000 selections in the 2024 batch. So yeah, do check out the course and I'll link this in the description below. Thank you, and we will meet in the next video.